How's it going, everyone? Welcome. Javier Gonzalez here, looking at dynamic key generation, which is part of the model of working with state. With Again, this is a course taught by Josh Komura, so a software engineer that has previously worked at several companies, Khan Academy and Gatsby. All right. So, uh, right now, what we are doing is to describing is the React nature. So again, pretty much like what I have done in other previous videos, for example with JavaScript, and what are the things that are around JavaScript. Okay, so not only is the basic features as well as the low level features, but also is what is around the spec. So this is pretty much of React here. To understand now, not only is the low level features or the things that allows to do, but also is the things that are around it. Okay, so because on the model 0 we look at this introductions of React and what React is, and how you can now speed up things when it comes to learn stuff. All right. The other is on model 1 is to describe is how do we get here at this moment. Okay, which is by looking is at the React. What's the problem that React is solved or is aims to solve? Why React? Who made this? What was the problem that, for example, Facebook have at that moment? And then how can we create our own React applications uh, by not only using is JavaScript for the web, but also is to target is mobile application, which is the reason why I'm getting hired to, as well as the uh, web WebLG 3, for example, 3D animations. Okay, so in each one of those platforms, they expose certain directives that you can now is recreate from that. Okay, so in order to understand now what are this user interface would looks like, we look at least at the web how to create that. What is this UI look like as a JSON that describe is the current state at that particular moment when we call is the create element from React. So in that line, we also look at how lengthy and verbose it is to create all of these components, and especially when you are combining is different user interface, how it can be quite uh, cumbersome to define is a lot of these user elements here. It can be quite repetitive and monotonous. So with that, we look at the GSX, what the GSX is aiming for, and why GSX is now. So what is GSX, and how can we translate or transpile into JavaScript to now let the browser understand is how the UI will look like when it execute our code, aka our front end code. And also is that because the most common thing that we do as building user interface is rendering lists and working with forms. All right, so for example this model, so when it comes to understand now how is this project look like, this React project look like, we first look at the elements, or the index, which is like the configuration file where you put things here like the config and so on, the config as well as the how do you put it, the CSS file as well, the app.js, which is the home base app, and the ES models, or aka the components, and how the components will look like. What is the anatomy of the component? What is a component? And what are the things that we can have access to a component, which is the props and the children, and how that is injected at runtime. So because again, most of the time as front-end developers, we're gonna write is we're gonna those applications will need to rendering its list of collections or fill a form. So for the first, well, we look at how can we rendering collections of elements in this sequence, in this sequential base, using is the map functions, and some of the trade-off of using the map functions. And also another common thing we do is to conditionally rendering elements here, such as, well, using the if statement like early returns, or the uh, using the ampersand, uh, or the ternary operator, as well as the CSS class. All right, this is useful especially for accessibility. Now, on that topic, okay, and because another thing is how we're going to style our components. So we look at the different methodology that CSS use, like bend, and how now we end up with this CSS model, which what it does is to now generate is these selectors based on the custom names as well as a particular hash. So you can now have access at JavaScript or GSS at your components like an object, right? So all of this is just to describe is these common things that we do when it comes to work with user interface statically, most likely, and also is to rendering is dynamic content. But when it comes to now understand, for example, is how can we add interactivity to the users. So we look at how we previously or how now we traditionally do in HTML, CSS, and JavaScript. Like, hey, let me take now is select that element, document selector, so document query selector, select that element, and therefore, all right, let me then is to uh, attach an event listener to that. So this is one option, and the other is, hey, let me now is put a function call when the user, for example, perform an action, an event, or trigger an event here. Okay, so far so good, no problem. Now, because the way how React handles this is quite different, is going to pass now a function reference. So by the time that by the time that the user trigger that event, you want to notify React about that event. Okay, so and speaking of these events, which is another thing that is, hey, how can we now is not only listen to user events, but also how can we now provide interactivity, this feedback loop to the user? Well, it turns out that now, in order to React notify that something changed, you have the use state hook, which say, hey, let me now is allow you to follow a conventions where I'm gonna give you the value and the function setter, all right? And anytime that you want to set this value, this is the function that you must use. So this particularly mechanism that work is hey, um yeah, that works is so this mechanism that works is on saying, hey, uh, anytime that you now trigger and state update. All right. So React, what it's gonna do, because it's going to transform your component from JSX into JavaScript, which is the React create elements. And once that function is called, it's going to generate now this JSON object here. So this is the sequence. This is the thought process. Okay. So when it generates this JSON object that represents the UI at that particular moment, all right, if there any change of that, React is going to now, through the diffing algorithm, spot the difference, and it's going to now, uh, after that, edit the DOM in a surgical, with a surgical precision, that say, hey, now the DOM has been updated and it's up to the browser to detect those changes and then repaint that UI that match and repaint that section to match the UI. So because this particular process have two phases, it can be either on the initial loading of your application, and this is why it is important to understand now how JavaScript see programs, okay? How each files, how JavaScript see all of these files as a single program by default, or how multiple JavaScript files can cooperate or act as a single program, all right, at runtime, of course. Uh, so because that the way of how we load this JavaScript code, it can be in two phases. Whether it is initially, all right, which is what happened at the beginning when the code is loaded. Well, so React now is going to mount that, and then it's going to call all of those functions and append all of those DOM elements, all of those elements into the DOM. This is on the initial render. So on subsequent renders, okay, so when a state change in one of those components, so React now knows that, because it exposed these particular hooks to keep track of those state change, and therefore is going to uh, re-render that component, which is just a fancy way to say spot the difference, aka call that function and execute, that is gonna give you this new snapshot of the UI and all of the subsequent snapshot of the UI along the render tree. All right, so it's going to unfortunately call all of those UI elements unless you use, for example, some other hooks that React provides. So for example, that is use memo or use callback. So this is now a way for React to keep track of those components and say, hey, if one of them change, uh, okay, if one of them change based on an array of dependency, all right, so let me now update that. Otherwise, does not. But again, all of this hook is just now like similar, like the browser is like this mini private investigator that track every little thing you do in the on that. So on the event, this is pretty much the same as when it exposed this particularly hooks. It, because you say, hey, use a state, this is the way how I'm going to now keep track of a state change. Use callbacks or use memo, this is now how I'm going to keep internally is some sort of record that map is if this particular function or component needs to be reevaluated based on an array of uh, dependency. So, and the other, all right, is this is, hey, again, I'm talking about is just the use stay hook right now for the sake of the example. Uh, And also is this definition of the rendering and the painting or repainting. So rendering in the context of computer or graphic application, it means that hey, let's gonna take this um, application, okay? Yeah, let's gonna take this unprocessed raw input and generate a ready to be used output. All right. But in the case of React, this renderings means different. It means that it's going to spot the difference between different snapshots. And this is when the second phase uh, happens, when a re-renders occurs. So in any case, the TLDR is that on the initial rendering, React what it's gonna do is to now evaluate and aka call all of these components and append those elements into the DOM. All right. So this is on the initial mount, and then when a component triggers and I say updates, it say okay. So now let me is uh, detect which component caused that, all right, and now evaluate that component, and if that component contains more React elements, I'm going to continue to call them until there is no more. And anytime that I call this, I'm generating is a JSON that describing is the current state of the new application, aka effectively creating this new snapshot here. So now that it has the previous snapshot and the new snapshot, then it's going to spot the difference through the diffing algorithm, which is a fancy algorithm that is used to do that. And then now that it knows what changed, so it's going to edit on the commit phase, it's going to edit those uh, DOM elements, and therefore now the browser detects those changes and repaints that UI that match that paints that section um, to match the UI. So all of this is just to describe that this particular event, and because renders and repainting they means different things, at least in this context. So not all re-renders triggers a repaints, because if there is no difference among the among snapshots, so React won't edit any DOM elements, like aka it won't trigger a browser paint. So this understanding of this course, the exercise, is quite important, uh, since it now reveal is that at the end of the day, React is anytime that we use it is going to keep track is not only user events, but also it's going to provide us is hooks that is going to be used to keep track of. So far so good, because next is how then we work with forms, all right, specifically with the dynamic nature of all of these different inputs. And because we have now inputs and selects and radio and checks and radio and check boxes. Uh, so how, and also is text area. So React now creates this convenient patterns to actually uh, do a data binding on these inputs. So you have now the value and the event that you want to listen, especially on change, all right? And therefore, it's going to now update that particular value as it is. Another important thing is that this updates of the states happens uh, asynchronously, all right, happens after the events, or after the chain um, or happen in the next ticks, as I mentioned here. asynchronous updates. It doesn't happen immediately. So you can batch a several state updates in your handlers. So this is one. And the other is that because when you work with forms, you have, as I mentioned it before, all of these different particularity elements and inputs, yada yada yada. So React create now this convenient wrapper around this and say, hey, if you want me to control this input, well, this is how you should do. This is the value and this is the on-chain. If it's not, well, don't do that or just rely on browser native behaviors. But don't switch from one to another. All right, make your mind. Make your mind. And that is when you define, for example, like undefine and empty string values. So we also look at how can we start to work with, for example, is well inputs, select, as well as the radio and checkbox, which is by far the most common one. So working with text boxes, or working with inputs, how you can bind the data, pretty straightforward. All right, with the event and the event handlers, with the value and the event handlers. And in the case of select, you define is the value and the on-chain you're going to receive that because it's using as a React wrapper. You're going to receive now that selected value that you can now update to that. And define, for example, is the options of exactly defining a series of options elements in the select, all right, and dynamically render those elements, well, using is a map function. Okay. And also how you can, for example, is extract some of the key and value from a dictionary, like by saying, hey, give me is all of the keys for that, or give me all of these entries. So you have now is this dictionary transformed into an array where each one of those elements will have is now, and the first position is the index and the second position is the array, right? So for example, if you do something like diggy diggy, if you do something, for example, like this in this dictionary, like, right, when you have now, hey, this is Argentina, right? And then you have the name Argentina, and then you have now another one, say is, hey, Venezuela, right? Venezuela, and then you have is now the USA, right? The US. So you say Unite USA to make it sure, right? USA, right? And then you want to assign this to an object of, let's say, countries, right? And then if you want to only get this key value pair, you might say, hey, I want to store this into a countries, okay, countries list, so to speaking, all right, and then do this, for example, hey, globally object, please give me is the entries, all right, of this object, all right, and transform all of these entries into that, right? So for example, if I want to iterate through these elements using this, let in countries of in of, because this is a collection. Countries is an iterable, sorry, in list. Okay, and then I want to do is, well, console.log and say countries here. One fancy way to do this is to say, hey, I want to destructure this and say, hey, the first value will be is now the key, all right, and the second value will be is the value as it is, all right, and what I can do is just to bring is the key and the value as it is, right. Unexpected string, which line, line 2, unexpected string. Oh, there you go. You are absolutely right. Okay. You are absolutely right. Okay. And as you can see, it's this one, right? So you have now this array of the R in Argentina. And if you want to understand what is this country list, well, it's now this collection of this key value pair in this element that contain is the array and the Argentina. Right? Again, all of these are convenient ways of how we can now convert is this object into now a collections of values. Okay, so on that line, and because as we look at how to work with select and also how to work with radio buttons and checkboxes, that it is important to define is the HTML4 in labels, and the name that will be used for the radio buttons to say, hey, this is a group that this radio or checkboxes group belongs to, and the ID to actually match is with that label and the button or the input button. So then we talk about now the props and states, and now how props at the end of the day is just a way of how you can pass down data from parent to children. So far so good. No, not any, not any problem, not any different things in that regard. All right, and working with complex states, aka is that why is that we need to pass a new state to these setter functions, so now React can keep track of this. Well, if you now think a little bit of that, if you want to find out that when you receive a in a function, when you receive is a value that is different, all right. So for example, let's take a look at this example and say, hey, this is now the function here, use state, all right. And here you define is the argument as it is, right. And this use state, or for the sake of the example, let's go just to say this, right. I do want to return now is the argument, all right. But because yeah, something like this, pretty straightforward. These arguments, all right. The question is that for primitive, we know when a value change, because we can say something like this. We can say, hey, it's gonna store that. We already have our store, and if we want to keep track of that or create a closure of that, we can say, hey, I want to return now this function here, that somehow, all right, it allowed me to is um, well, update that state. You know, you say, hey, if the arg is different, all right. So if the arg is different to this new value that we receive here, okay. So if the initial argument that we receive is different to the new value, all right. Well, good. I can now return this new value. So return the new value, sort of speaking. And why this is important? Because for primitive, well, it makes quite sense to actually verify that, you know. So if they are primitive, so if they are any kind of primitive, right? Um, we can actually know when something has changed. All right, and for primitive we can say, hey, if this is the type of if type of arg is equal to undefined or or null, and so on and so forth, right? So for primitive, it is quite easy to know if two difference are if two values are different. But for complex states, all right, how do you actually verify that two different objects are different in its content, not in its reference? And this makes a lot of sense to say, hey, it is preferable to React, given the JavaScript constraint, that provides a new state of this object, that provides a new state of complex objects, right? So this is why we look at this particular example at that, and why we actually need to pass this new object, whether it's an array or an object, a set, map, whatever you want to call it, okay, or even functions, all right. But most likely we don't use these functions for this, only to initialize its value. And when we do that, we're saying, hey, this is the initial value that we're gonna have here. Now, we're looking here at the dynamic key generation. So in the last model, we learned about React keys when iterating over data with .map. We need to give each React elements a unique key attribute so that React know which DOMs operations to trigger between renders. In the early examples, our data conveniently came up with unique tokens for each item, like this. And we were able to use those tokens. But what happened when we do need to generate is those key for us? But what if our data doesn't have any unique token here? In fact, this is one of the most common questions that developers has. React needs a unique value for each item, but we don't always have one. And let's explore with an example. So stickers. In the sandbox below, you can click to produce a randomized sticker here. Right? This actually produce a randomized sticker. So the core logic has been completed, okay? So we are getting a key warning in the console log. Fix it. I'll walk through exactly how this code works and how we can solve this problem. But I encourage you to spend a few minutes tinkering with yourself to see if you can understand what's going on in any of these code solutions. So this is the sticker pad. Okay, click around. But there is an error here. Each child in a list should have a unique key props. Okay, so if you reload this, it gives you this sticker, all right, a randomized sticker, but it tells you that it say, hey, the sticker pad, the sticker data, all right, that this doesn't contain any unique identifiers here, all right. And what it does is to get sticker is just to say, hey, sample must be a function here, which say, hey, call select a sticker randomly from the array. So return the sample, and the sample say, hey, this is the sticker, and say, hey, let me now take that array, okay, and randomly get that. Right? You say mat.random array.length. All right, so multiply this value for whatever you have in the collections, and then now get me is the upper number. All right. In this case, it worked for this. Okay, because this will give you now from 0 to 1, and if you multiply it for any of the elements, it will give you is one of those elements. Okay. And you with a point fix definition, and then I just only wants to get is the math floor, this the upper level, the upper number, and then assign this to this. So now I can actually get that as it is, right? And this is now preload image. Say, hey, sticker for each one of them. I want you to now is create this new image, and they say, hey, preload all of the image so they are immediately available on click. Note, normally I will do this. Normally I will do this inside the component in a use effect hook, but we haven't learned that yet. So we'll learn more about that, how to tackle challenge like this in Model 3. But is this, right? So then you're gonna load this preload model. This is the CSS, okay? And some of the components. Hey, I want you to keep track of these collections of values dynamically, and anytime that the user click on this component, all right? I do want is to now create this new sticker, and then now add that with the X and G, and you're going to render that element there. When the user click, a sticker should be placed right under the cursor. Well, actually it doesn't place under the cursor. To accomplish this, we're sliding upon the left by 15 with its size, and drop a shadow here, which is the sticker. Exactly, it must appear that. It must be rendering that. So when this actually change, you say, hey, let me now update the value of this sticker, of this collection. So it's gonna render all of these collections and render all of this collection with this new one, and so on and so forth, and then you get it, right? But it has this, right? So the thing here is that how can we now is pass a dynamic value here, okay?
So I have to admit, I had way too much fun creating this exercise. There's something just so nice and playful about being able to click and add stickers. And while I recognize that the result of this work looks pretty straightforward and pretty simple, I also know that the code to do this is pretty complex. And it's not really that we're doing anything that drastically different from what we talked about in the complex state lesson, but it is sort of putting all those ideas right in place right after we learn them. So before we talk about the keys, I want to briefly go over how this code works. And essentially, it starts with this onClick event, where when I click on this button, which with CSS has been made to fill the viewport, I start by getting a new sticker object. This method exists in the stickers.data file, and we can look into that file to see what those objects are. Essentially, every possible shape, like the cactus or the cat or the heart, has an object describing it with the image's source, some alt text, and its dimensions. And so I pick one of these objects at random, and then I augment it with my own little bit of data. The thing that I want to know is where the user's cursor is, so I can put the sticker right where they happen to click, and I can get that data from the synthetic event. So client X refers to the number of horizontal pixels from the left edge. Client Y refers to the number of vertical pixels from the top edge. And so we can imagine, right, if I was able to tuck my cursor right into the top left corner, then both of those numbers would be 0. With this new sticker, I create a brand new array that includes all of the old stickers and this new one. This is kind of like pushing into the array, but doing it without modifying the existing stickers array. And then I call the setStickers method with this new array. This sticker's state starts life as an empty array, but whenever it changes, it triggers a re-render. And inside this little part of the render, I am iterating over those stickers and creating an image for each one. I'm using all the data that we saw from that stickers.data file, like the source, the alt, the width, and the height, and then I'm also using the left and top to position it. I know that I am kind of glossing over the styles. You can poke into that at your own leisure, but I want to focus on the JavaScript and React stuff. And the problem here is if we look at the console, we have a warning about keys. In order for React to be able to work in the most optimal way, it needs a unique identifier for each of these images inside the stickers array, and we haven't given it one. And it's tricky because, we don't really have any sort of unique identifier. Like, the only thing I have are the 4 properties described here, and then the user's cursor position. And so we could try making it equal to sticker.src, and if I refresh the page, the moment I have 2 of the same sticker, so there we are, yeah. The moment I have these 2 stars, I'm going to get a warning that this key, images/stickers/star.svg, well, it's not unique anymore because I have 2 images with that exact key. And we could make this a bit better by sort of like dynamically creating a string consisting of multiple properties. So let's say I start with the src, and I also include sticker.x, right? That's the horizontal distance from the left edge of the screen that this particular sticker happens to live at. And then I can do the same thing with sticker.y. And this is better, right? Like we won't have the warning right now because the 2 stars aren't in the same place. But there's nothing stopping the user from sitting with the cursor in the exact same spot and just banging out sticker after sticker after sticker. And if we check the console, we see that our effort to create a unique key has once again failed. In fact, there's no combination of properties that I can use here because the 2 stickers in the exact same spot are identical in every way. So what if, instead of trying to construct a key from that, we decided to use a totally random value, like math.random? Well, when I do this, I can create a bunch of stickers in the exact same spot, and the console doesn't have any warnings, but this is still not really a good idea. And I do see this sort of mentioned online sometimes as a decent thing you can do, but it really isn't worth doing. And the reason for that is performance. If we think about what the keys actually do, right? What is the role of this key attribute? Well, it's to help React understand how things should change when things update. And so let's imagine now I start with my snapping fingers sticker over here, and let's pretend that when this first renders, the random number that it selects was 1. Now, of course, it wouldn't really be 1, it would be 0 dot and a bunch of decimals, but to keep life simple, let's imagine that it was 1. Then I click over here, and we add a new sticker, so the component re-renders. And let's suppose that now the numbers are 2 and 3. the number changes because whenever the component renders, we run this code, and math.random will spit out a new, different number every time. And so what that means, what we've told React, is that the snapping finger sticker, that's gone, right? The one that had the ID 1, that's no longer here. We now have a new array with two brand new stickers. We have sticker number 2 and sticker number 3. And so React will bulldoze away that initial image, right? Destroy the image, remove it from the DOM, and create a brand new image with all the same properties. It's identical in every way, but it still had to delete and reconstruct it because we told React with the key property that that's not image number 1 anymore. That's done with. Now this is image number 2. And if I click again to add another one, it comes up with new IDs for all 3 of them, and bulldozes away the bunny and the snapping fingers that I had and reconstructs them too. And so as I add more and more stickers, I'm just making the browser do more and more unnecessary work, destroying images that were perfectly fine and could have stayed, and recreating them. But the underlying idea here, right, the idea of creating a unique random value for each sticker, that's not a terrible idea. The problem is that we don't want to do it in the render where it changes every time we update the stickers array. But what if we did it inside the click handler? What if on the sticker object I set ID equal to math.random? Then inside the actual mapping array section, I can say sticker.id. I'm going to log this out because I think that'll be useful. Console.log stickers. And when I first click to create a donut, we see that it has the random number of 0.80. If I click again to create another sticker, notice what happens. Now we have a new cat that has its own unique ID, but the donut is still 0.809, right? The ID is consistent because we're only calling this math.random when we first generate that particular sticker. Every other render, we're using that static value. So we've created a persistent ID, a real unique identifier that says this donut has number 0.809, and no matter what happens as we add new stickers, that ID is consistent, and React will really know whether or not it has to do any work with it. I'm using math.random here, but really there's any number of ways we could do this. I could maybe even use dates.now if I could trust that the user couldn't click faster than whatever metric it uses for coming up with new timestamps. There's also, I learned this recently, there's crypto.randomuuid, and don't worry, this is cryptography, not cryptocurrency. We're not getting into that kind of stuff here. But this essentially generates a new UUID, and if you haven't seen those before, they're like random numbers, but they have a bit of a different syntax, like they look like this. And I suppose there is the advantage that it's less likely for something of this length to have a collision, right? The odds of generating two different UUIDs that are the same are completely astronomically low. But then again, right, the odds of two numbers with this many decimal places being duplicates, it's already low enough that we're talking like winning the lottery 100 times in a row kind of odds. But yeah, this is the strategy, right? Create a unique identifier whenever we create the object. And while you might be thinking that this is a pretty contrived example, right? Like how often do you create clickable stickers? It's the exact same practice if you're fetching data from a network, right? The moment you get that data back, you can go through and add unique identifiers to every item in the array if they don't have them already. This is a trick that I use over and over and over again, and I think it works super well.
Crypto random UUID. But now you're relying on some web APIs to do so. And the key gotchas.
So in the previous lesson, I shared my go-to solution for situations where we have some sort of data and the data doesn't have any built-in unique identifier. My solution is to generate one using the crypto.randomuuid method, and I do this right as the data is first created. So in the situation when the user clicks to post a sticker, we're already doing all this work to generate the sticker object. Why not give it a unique identifier at the same time? Then, when I'm mapping over the data, I can use that ID as the key. Now, you might be wondering why I chose to structure things this way, when there are solutions to this problem which are arguably quite a bit simpler. The thing is, this approach will work in every situation. It's incredibly flexible, while other solutions might work in this situation, but they can cause big problems in other situations, everything from significant performance issues to baffling UI bugs. In this lesson, I want to do a bit of a deep dive into this. So we're going to look at some of the simpler solutions, but also see some scenarios where they don't quite work and the problems that can ensue. So the first alternative solution I want to explore is, instead of using the crypto.random UID method, what if we use the length of the stickers array? I've heard from quite a few students who have structured things this way, and we're wondering if it causes any problems or not. And the way it works is actually quite clever. When I click to create the first sticker, stickers is an empty array. That's what we initialize the state variable to, and so stickers.length is 0. Then, when I click to add a second sticker, well, at that point, the stickers array includes the first sticker, and so the length resolves to 1. And essentially what we've done here is created an auto-incrementing ID. So the first sticker is 0, the second sticker is 1, then 2, then 3, then 4, and so on. So that's one solution that will work in this situation, but we can make it even simpler. How about, instead of doing anything at the moment when the sticker is created, we instead rely on the position of the sticker within the array. When we call that map, we get not only the data itself, but also the index of that data, the position of this particular sticker within the array, and I can use that index as the key. It actually produces the exact same result as our auto-incrementing alternative, where the first sticker is going to be 0, because it's the first sticker in the array, the second one will be 1, and so on. And so it does work in this situation, right? The requirement of a key is that it uniquely identifies each item within the array. And indeed, we won't have any two items that share the same array index. But like I mentioned, it can cause pretty significant problems in other situations. Let's take a look at one of those situations. Things are pretty similar. I still have the ability to click to add stickers, but now I can right-click to delete stickers. In order for this new functionality to work properly, I did have to change the structure a little bit, and so now each sticker is still an image, but they each have their own buttons. So essentially, this is now a little button that contains the image, and it's the button that I'm positioning around, and that also listens for right-clicks so that I can delete them. I'm also using the array index as the key, and I've added a data attribute that mirrors the same value, because I wanted to have a way to actually see the key inside the DevTools. So if I click to add a bunch of stickers, well, then I can see what the key is being set to via this data attribute. Now, the problem with using the array index as the key in this scenario is that it forces React to do a heck of a lot more work whenever we start deleting items. For example, I'm going to right-click on the cactus to delete it. Notice what happens to all of the other buttons that aren't actually supposed to be affected by this. I click the cactus, and wow, that's a lot of things that happen to change there. Let's look at this again in slow motion. I click on the cactus, and everything else changes. To explain what's going on here, I've created a little visualization of this in Figma, showing what I'm telling React is the unique identifier for each sticker. So initially, our cactus is given a unique ID of 0, because it's the first item in the array. The exclamation mark is given an ID of 1, and so on. When I right-click on the cactus to delete the cactus, I'm not actually deleting this image element. I'm not deleting the image element associated with the ID of 0. Because just think about what the set of keys is on the next render. We're going to go from having 0 through 4 to having 0 through 3, right? We're not going to have the indexes be 1 to 4, because the index is always based on the position of the array. And so when I delete the cactus, what winds up happening is that each of the other 4 items sort of shifts forward in the array. And now it's the exclamation mark that has the index of 0. To look at this another way, I'm going to show this sort of additional to the table, and I'll zoom out so that we can see it. What winds up happening when I right-click on the cactus is that we actually delete the 5th item, right? The item with ID of 4. This button with the image element inside gets deleted. Then React has to do a bunch of work to change the heart into a donut, the star into a heart, and so on. To walk through this in the browser, right? Right now I have IDs 0 through 4. I right-click on the cactus, and then it's the ID 4 that gets deleted, because on the next render I still have 0, 1, 2, and 3. So we start by deleting the 5th item, but then the other 4 items are all wrong. So for the ID 3, which is currently showing as a heart, React has to go in and change that image from a heart to a donut. Then we have to change its size and position, so we have to make a bunch of tweaks, right? We have to slide it over to the side, and then we have to make it bigger. Right? We have to do all this work to make it appear that nothing has changed with the other 4 stickers. Now, earlier I mentioned there's another alternative solution that students were wondering about, which is to still create a unique ID when we generate the sticker, but rather than using a random number, what if we use the length of the sticker's array? Well, and I have to make sure not to forget to change the actual key to sticker.id, and I'll do the same thing for our data attribute. Now things actually seem to work pretty well. If I have my same 5 stickers, I'll select the first one, and we'll keep an eye on the DevTools as I delete it, and check it out. None of the other 4 buttons had to change. This is actually working as intended. Right now, we go from having IDs 0 through 4 to having 1 through 4. When I deleted the first cactus sticker with ID 0, we also deleted the button with data ID 0, or really key 0. But this solution has a new problem. Notice what happens when I go to add another sticker. Well, now the key for this new sticker is the same as the previous one, and if I look in the console, I have a warning about this. To explain what's going on here, I have another Figma visualization. So once again, we start with the same 5 stickers with the same unique IDs. I delete the cactus, we delete the associated ID. So far, everything is hunky-dory. But then, when I go to add a new sticker, right, so I click, we get our bunny sticker. We calculate the ID for the sticker based on the number of stickers in the array, which right now is equal to 4. As a result, 2 of the items in our stickers array share the same ID, and this is like one of the worst things we can do. Like, this really confuses React. And so this is really why I prefer to use a method like crypto.randomuid, or you can use math.random if you prefer. Either way, by using a random value like this, we're guaranteeing that each sticker will always have a truly unique ID, no matter what I do to the data. Now, before we wrap up, I want to look at one more example. In this scenario, I have this list of strings that I'm holding in an array in React State. I'm mapping over those invitees, generating a list item for each one, and including an input that holds that value and a button I can click to delete this particular list item. I do see I have a warning in the console telling me that each child has to have a key. So let's see what happens if I solve this problem by using the array index as the key. Well, initially things seem okay. I don't have any console warnings and everything seems to be rendering correctly. But let's see what happens when I decide to uninvite Mr. Jameson from my birthday party. I click the delete button, and he's still here. We lose and may, curiously. If I click it again, we see that he's the only one left. The rational assumption is that I must have made some sort of mistake with my delete logic, right? Like clearly I'm deleting the wrong item from this array. Well, we can check that by logging the invitee's state, and I see that initially everything looks correct, right? I have the same 3 items in this array as I have in the UI. When I click to delete Mr. Jameson, though, we see that things start to diverge. The state actually looks correct, like I've removed this item from the array, but the UI still shows only the first 2 people from the initial state. To explain what's going on here, I think it'll be helpful if I include the index within the UI. That way we can visualize what we're telling React is the key. And so we see here that what I'm saying to React is that this list item is uniquely identified by the number 0, this one is uniquely identified by 1, and this one by 2. When I click to delete Mr. Jameson, we wind up with this new array. Mary Jane now has a unique ID of 0 because it's now the first string in this array, and May has an ID of 1, and there is no more element with the ID of 2. And so what React does is it deletes this third list item. Now, I should confess, I'm doing something a little bit strange here. Maybe you've been wondering what's going on with this default value. The idea is that this is a way for us to populate an input with a particular value without explicitly binding it to React state. So when the page loads and React renders for the first time, we tell React that this input should have an initial value of whatever this happens to be, right? For the first input, this is going to be the string J. Jonah Jameson. But after that, React takes a step back. and it no longer actively manages whatever's in this input, right? Whatever text I now type in this input is outside of React's purview.
Exactly.
And so when I go to delete Mr. Jameson, we wind up removing the list item with ID of 2, and even though we're changing the value of invitees, that has no effect on the text within these two inputs because React isn't actively managing them, and so these two inputs will keep displaying whatever they happen to be displaying without React getting involved. Now, I'm not saying we should actually structure our code this way. Like, I'm using default value here as an example for the sorts of UI bugs you can run into when you're not using keys correctly. By using the array index as the key, we essentially tell React to delete the wrong list item. Like, I want to get rid of this one, but React winds up deleting this one. And in some cases, this seems to work all right, because React does a bunch of extra work to hide this mistake from the user. For example, if I right-click to delete the cactus, it's actually going to delete the bunny sticker, and then it has to modify the other 5 stickers so that it doesn't appear that they've changed, but it can't always do that if something lives outside of React's domain. So I recognize that this stuff is very, very challenging. We're really getting in some pretty advanced territory here. But the good news is that you don't actually have to have a crystal clear understanding of this. As long as you follow the pattern we showed earlier, where we generate a random value to use as the ID at the moment the data is created, you never have to worry about any of this because you're never going to run into any problems.
And because React is keep tracking this as a collections, and if one of the elements has removed from that, then React not only have to do all the works to compute that. This is one. If you use now the index, and there you got it. And then now
here's the
lift the
scenario.
state up. Yeah, lifting the state up. If you have spent time in React communities, there is a good chance you are over here the term lift state up. It sort of becomes the catchphrase of React developers. There is a good reason for this. Lifting state up is an incredibly important idea and vital tool in every React developer toolbox. As a result, this is one of the most critical lessons in this entire course. We'll explore the concept of listing and stay up by seeing how it helps us with the same application here. So for example here's the original code from this, right? And here's the final code with the state lift up, which is created now is a new, is omitted. Okay, what you have now this, and then you lift the state up here. So what happens is that when you're going to now pass down the data, this will expect. So this will now is, again, you are telling to React, please, I want you to now keep track of this state, and whenever a state change happen down the tree, all right, I want you to now update this state and therefore trigger all of this. And this is something that can cause a lot of problems.
Yeah, you've been contracted by a local fruit vendor who wants to harness the power of the internet to sell her fruits online. And you started implementing it, but you hit a bit of a snag. You're working on the search feature so that the person can type the word mango and click search. And ideally, at this point, you would see the phrase "you searched for mango" as well as the search results below. Now, there's a data fetching component to this, right? I would need to make an API request to a backend to fetch all the information about the mangoes from our database. That's kind of a whole separate thing. Like, we're going to talk all about data fetching in the next module, so we're not going to talk about that today. But we're going to talk about something much more foundational and, dare I say, much trickier, which is, how do I show the word mango over here? And the reason this is trickier than it might sound is because of how our application is structured. So let's look at that. We have our app.js, which is the home base of our application, and it renders two children components. It renders search form, which is this business over here, and it also renders search results, which is pretty much everything below the header. If we look at search form, we see that it has a state hook, a bit of state called search term. That's the state that currently holds the word mango. And we're using it, we're controlling this input with it. So we're passing the value, and we're also doing the standard wiring so that when I type in this input, it updates the state. And this is why it's tricky, because the text down here is in a totally different component. It's in search results.js. And so what I want to do is I want to put search term over here, right? That's the wiring I want. But when I do that, I get an error because I don't have access to that. I've taken the liberty of kind of diagramming this out, showing the relationship. And what this shows is the parent-child relationship. So we have app.js, which renders two children component. It renders search form and search results. And search form is the one that holds the state for the actual search term. Now, I think when a lot of developers run into this problem, the natural inclination is to reach across the aisle and kind of snatch up the bit of state that I need. And this is how it works in some of the tools that I've used. When I used to work with Backbone, there was a bunch of this where any part of the application could access any other part of the application in terms of its data or its state. So search results could kind of reach in and grab this thing. Search form might reach in and grab some other thing. And the problem when you structure applications like this is over time you wind up with this big hot mess of spaghetti where everything is pointing to everything. And it gets to the point where you might wonder, like, can I change or remove this bit of state? What far-flung corner of the application will I break by doing that? Because there's usually very poor visibility into how all these things are wired up. And I think React solves this problem in a rather elegant way, which is the rule in React is that data can only pass through components via props or via context. And we're going to talk more about context later. It's kind of fancy props is how I might describe it. But essentially, we have to follow the lines of our application. So if I had some data in app, it would be able to pass that data down to its children through props. So the way that we solve this problem is we have to lift the state up. We have to take the state that currently lives inside search form, and we have to lift it higher in the tree so that as long as we can connect it with one of these lines, right, as long as a parent can pass it to a child, that's how the whole data flow works. They also call this unidirectional data flow. You've heard that term before, which is parents can pass to children, but children can't pass to parents, and siblings can't pass to siblings. It always goes in this singular direction. So let's see how we'd actually wire that up. I'm going to go into search form, I'm going to grab this state hook, and I'm going to bring it so that it lifts. Calling whenever the input changes. Now, I know that this can kind of hurt your brain the first time you run into it, but it is kind of really weird, and it feels like this overly engineered thing. So I want to walk through it kind of step by step so we can see exactly what's happening here. And I'm going to start by removing cat food as the default value, and we're going to kind of walk through what happens when I make a single change to this input. So let's suppose I type the letter A. Well, the first thing that happens inside search form is that this input fires a change event, right? Something has changed, JavaScript says, and React wraps that, and it fires off the change listener. So because I've passed it a function, it's going to invoke this function. This function then immediately calls the setSearchTerm function, passing in the new value, which in this case is the letter A. Whenever you call a state setter function in React, it's going to re-render the component that owns that bit of state. So because the search term state is owned by app, the app component re-renders. And this is an easy thing to misunderstand, because you might say, well, it's being called inside search form, so shouldn't it be search form that re-renders? Well, not really, because app.js is the component that owns that state. There's this indelible bond between the search term state and the app.js component. Whenever search term changes, app re-renders. And so when it re-renders, what that actually means is it calls this function again, except now search term is equal to a new value. It's equal to the letter A. And so it renders all of these elements again. It's going to call the search form component again, except now search term is equal to the letter A. So when search term re-renders, it's updating this control component with that new value. And when search results re-renders, search term is now equal to the string A. Okay, there's one more thing I want to talk about before we wrap up. And I've taken the liberty of drawing yet another little diagram. Quite a bit more components this time, but a very similar setup, which is I have a search form component and a search results component, and the same search term state. And the question is, where do I lift this state to now? Well, you might think, let's skip all the trouble of figuring this out and just move it all the way to the top, right? Let's move it to app.js. That way every component in the entire application can access it if needed. And this does make a certain kind of sense, but it's generally not what you want to do in React. And that's for a couple of reasons. The first is performance. Because we only want to re-render the components that require the data. And so if we say maybe these two components are the two that need it, I'm going to give them like a light pink color so that we can keep track of that. Well, if I do it this way, then something else and footer are going to have to re-render every time it changes, even though they don't care about that data. The other thing is just like code organization. Like my blog, which is not a particularly huge or complicated application, has about 200 state hooks. And so you can imagine if I moved all of them to app.js, that would be a very complicated component. I'd have to come up with unique names for every bit of state. It's just not the best way to do it. So here's what I propose instead. We should find the lowest ancestor. We want to move the state essentially as low as we can, but no lower. And so the closest shared ancestor to these two components that need it is header. So that is the right answer in this case. If we decide, for whatever reason, maybe we want to show the search term in the footer as well, we'll give that the same pink color. Well, now homepage is the closest ancestor that satisfies all of those components. We'll have to pass it through header, but we can do that. This is now the solution for that case. It can be a little tricky in some situations, and it does mean that every now and then you're going to have to go through the process of moving things. Much later in the course, we'll talk about how context can alleviate some of this as well. But essentially, this is our strategy, and that is how we lift state up.
And the other is components instance.
So I remember when I was first learning React, there was something that really confused me around state. Because, I understood in theory that you could update the state and the component would re-render, but I couldn't figure out where the state lived. Did React have some central store somewhere where it knew all of the state for all of the components? Were they associated with the elements I was rendering somehow? It just didn't make sense to me. And when I did finally learn the missing piece here, the thing that I was missing, it was like that puzzle piece that suddenly the rest of the puzzle starts coming into focus. It really helped me understand what was going on. And that puzzle piece is called component instances. So to help me explain this, I have a minimal React application. I'm doing the whole thing, right, including the create root and the render, because I really want to talk about the whole process from beginning to end. And so I import my dependencies, I define a component, I create a root, so I have this div ID root, I say this is where my React application is going to live, and then I render in a single React element that has the type of a random number. Random number is a component, so it means that we render this component, and this component has a little bit of state. So we start this num variable with the initial value of 0, we show that number inside the button, so I see current number 0, and I set up a click handler so that when I click on the button, we get like a huge mess of decimal numbers, but a different one every time. And this was the part that was confusing to me. Like, I have this num state variable, I'm kind of pulling it out of React, right? Because when this component re-renders, this function reruns, and so I need to get this value from somewhere, so I pull it out of React. But where am I pulling it from? Like, where does it live? Is it part of the random number element? Is there some sort of internal store for React data? I didn't really get it. And the thing that I learned is that when we call root.render and we pass it a component like this, we mount this component. And mounting a component consists of two parts. The first part, and we've talked about this a little bit already, is the process of figuring out what the JSX is. So it kind of goes through and it says, okay, you need a button, and it needs to have a click handler, it has some text. By the time we actually render this, the dynamic parts are resolved, so this squiggly bracket num becomes the number 0, so that's what this variable starts life as. And we take this description of the button, and we hand it off to React, and React says, oh, okay, you need a button, it needs to have a click handler, so it produces the real button, and that's what we see over here. It also sets up that click handler, so I can click on the button, well, when I don't intentionally break it, I can click on the button and get these new numbers. That's the first part of what happens. The second part is that we create a component instance. The very first time we render a component, it creates an object. And that object is essentially like a long-running process that knows all the contextual information about this particular instance of this component. Because we can have a bunch of different random numbers all over the page, But this one, the one that we're actually rendering over here, it gets its own instance that's managed by React, but it's like a discrete thing. And so we mount the component which creates this instance, and then over time, as we're changing the value, that value is stored on this instance. Now, in terms of the component lifecycle, right, we see that the component is mounted when we call root.render. That's where it's like sort of born, and then it lives on like as we're modifying things, as we're clicking the button. But really, this component lives forever, right? It's going to last until the heat death of the universe, or until the user closes the browser tab, whichever comes first. Because we're not really unmounting it anywhere. We're always rendering this element. So let's look at another example that has a little bit more dynamics involved with the instances. In this application, I have my app component. It has an include footer state variable, which is a Boolean value. I'm binding that value to this checkbox. So I have this little checkbox over here. When I click it, the value flips to true. If I click it again, it goes back to false. And if include footer is true, I'm conditionally rendering a footer element, which corresponds to this footer component we'll talk about in a second. The very first time we mount this application, right, when the app instance is created, during its initial render, it's going to go through and it's going to say, okay, you need an H1, you need a form. This value is false initially, which means this whole thing evaluates to false. And so React doesn't know anything about the footer at this point. It doesn't have a footer. But then, when I toggle the checkbox, right, when I click this little checkbox over here, now include footer is true, which means this entire expression resolves to this. And so at this moment, right after the page is loaded, React says, oh, you need a footer, do you? And so it creates a footer instance, and then it does the work of mounting that component, which includes rendering all of this stuff, right? Seeing that we need a footer and a form, and then making it so, right? Putting all that stuff into the DOM. This footer has its own little bit of state, right? We have this color selector, and we can kind of see, we can change the color of the footer, which I guess is kind of novel. It's really, really easy to make really gross color combinations, so please don't try this at home, or at least don't try this in production. But now, here's the interesting thing. I have this background color state, right? You see that I'm setting it as the background color over here. If I toggle this off, it helps if I actually leave the code that I had in. If I toggle this off now, the component goes away. If I toggle it back on, what color will the footer be? This is a question. You can pause the video if you want to think about it. Will it remain that disgusting olive color that I set, or will it revert to the initial dark blue? What do you think? Well, let's try it and see. When I click it again, it comes back as its original dark blue. And the reason for that, right? When I click this checkbox again, we go from having a footer in this spot to having nothing. And so React destroys the component instance. It unmounts the component. So it's going to realize, okay, you don't need this footer anymore, you don't need the form, it removes it from the DOM, but it deletes the instance. And the instance was the thing that it knew about this background color. That's where the state was being stored. And so if I keep clicking this, if I enable it again and again, I have to remember to stop breaking my own code. Every time I do this, right, every time I toggle it on and off and on and off, I'm creating and destroying a component instance. And when I destroy the instance, all of that state goes with it. One more little demo that I think drives this home. Let's create multiple footers. Let's do 3 of them. And so now, when I toggle it on, I have 3 separate footers. And because of that, I have 3 separate footer instances, which means I have 3 separate states of React state. And so each of these can be set to its own background color. They don't have to share the same color at all. It is just really hard coming up with nice-looking color combinations in this way. So each of them has their own state variable because they each have their own instance, and you can think of it almost like 3 parallel tracks, right? They all have their own value, and over time, this one renders, goes from blue to pink, and then this one renders, goes from pink to green.
Each one of those components
all of these instances are independent, and the moment we stop rendering their associated elements, that instance gets bulldozed away by React, right? Boiled away like water in a kettle that someone forgot to turn off. And that's the little bit that for me really helps solidify that state isn't this completely magical thing, right? React has an actual place for it, and every time we render a component like this, we create an instance. Now, I should also say, I actually remember when I first learned about instances back in 2016 or so, it was not an immediate light bulb moment. Like, honestly, it felt pretty overwhelming at the time because you have elements and components, and now there's component instances. Understanding the role each of these three things plays and the boundaries between them, that takes a while for the intuition to really settle. So please don't worry if you're feeling a bit overwhelmed or if you're feeling like most of this is going over your head. We're going to revisit these ideas throughout the course, and I bet if you come back and watch this video in a couple months, it'll make a lot more sense to you. And hopefully, at least in the meantime, some of the practical benefits can still be applied, like understanding that the state is tied to a particular component instance. So if you unmount the component and then remount it, that state is gone forever because you deleted the thing that was holding that state. Or the fact that if you have three React elements, one on top of the other, they're the same component, they all have their own version of state because they each have their own instance. So hopefully at least that was some immediate practical benefit. And please don't worry if the theoretical stuff takes a little bit longer to sink in.
Takes a little bit longer to sink in. Users login, users submit. I struggle to think of a case where I want to use it myself. Dan Abramov. So application type, not much state, mostly client state, mostly server state. Not much states, mostly server state, and the right tool for the job. For mostly static website in category 1, we don't really have to worry when it comes to global state. There isn't much of it. For client heavy application in category 2, Redux is awesome. I wouldn't go as far as say that it's necessary. React really has become much more capable in the past few years, but it's still a very helpful tool. Redux helps keep the code simple even as the features become more and more complex, and has a lot of built-in performance optimization. The category things get interesting when we talk about server-heavy application in category 3. The biggest state-related challenge in this category is all network-related. Fetching the right data at the right time. Make sure the data doesn't grow stale by revalidating it, fetching it again, and customizing the revalidation of specific situations. Catching the state so that multiple components don't repeat requests unnecessary. Optimistic UIs updates so that we predict how network requests will resolve. Impaginations, requesting small slice of the data and letting the user will pull new data as needed. Here's the thing, Redux doesn't really address any of them. Redux is a state management tool. It doesn't help you with network stuff. Over the past few years, several tools have popped up which are purpose built to help us manage this sort of network related challenge, server state challenge. These tools include Apollo, React Query, and SWR, and we'll learn more about them in Model 3. If you're building a video game or an audio editor, Redux is great, but most of us aren't building those sort of applications. I guess that 95% of applications are either 1 or 3. Exactly. Depend of other application as well. Depend of other applications. So for example, if you're building now React application, React Native applications, it is. And so this is the mental model I use when figuring out which tool to use. If it is a static website like my blog, I use React alone, with the help of context discussed in Model 4. It is a client-heavy applications like Beast Saber level editor. I use Redux for global state. If it is server-heavy applications like this course platform, I use React and some things to help with the network stuff. I'm using Vercels SWR on this course platform. and I have no compliance. This is the formula I have found work best after years of experience and dozens of projects. But a lot of this really does comes down to subjective preference. But here is something I can say pretty objective. React has evolved tremendously over the past few years and has become way more capable. And you can absolutely build large, sophisticated applications with it. If you're new to React, here's what I suggest. Spend a year or two getting comfortable building apps with React using the tool covered in this course. You can always explore Redux in the future and see if you find it helpful. Honestly, there aren't many wrong ways to build apps, so we live in an era of abundance. In React Toolkit and RTK, over the past year, the Redux team has been hard at work in creating Redux Toolkit, an opinionated toolset that aims to set down some of the rough edge of working with Redux. This toolkit includes a project RTK query, a tool which is more or less a Redux a compatible version of React querying and okay. hmm So the Redux toolkit is a nice little wrapper around the way of how we need to create states with actions and dispatch and following is this flow architecture. But RTK solved this particular problem. Hey, if our state now doesn't live on the client, if now live on the server, how what can we do? Mm, mm. I will be pretty excited about this development, but unfortunately, I have a fundamental disagreement with the opinions that are back into Redux toolkit. I'll share my Cuba below for anyone curious, but the takeaway is that I plan on continuing to use classic Redux without Redux toolkit. Mm. If you're already using Redux toolkit, I think RTK query is a slam dunk. It makes a slam dunk. It makes way much more sense to use something tightly integrated rather than trying to get Redux and SWR to play nicely together. Otherwise, it is hard for me to say whether you should use this combination over something else. It wouldn't be my first choice, but I say it above. There is a lot of great options out there, and this one might work best for you, depending on the type of your app you're building and your subjective preference. My cue is with Redux Toolkit. So I am mentioning about Redux Toolkit. It's an opinionated set of tools built on top of Redux which enforce a number of conventions. Regrettably, these conventions are not well aligned with how I personally prefer to use Redux. I should say before anything else that I have a ton of respect for the work that the Redux team has done. You should take everything I'm about to say with several large grains of salt. I could very well be an outlier. By and large, the community seems happy with Redux Toolkit. Alright, let me explain why my issue. Exactly. In Redux, here's the two distinct concepts, the actions and the reducers. We track things that happens. Exactly. Actions track things that happen. And reducer responds to actions by changing the state in some way. In classical Redux, actions were meant to be semantically distinct from reducers. It was seen as a bad thing. If your action has set in the name set user data, because actions are supposed to describe events, not dictate what those events affect. Exactly. What it does, not what it's affecting. The reducer is the one who decides what impacts the action has on the state. Okay. So the action defined is the name or describe the event, and the reducer describe is what the state change. So what action, okay, what impact that actions has on the state. Mm-hmm. This is important. The actions and the reducer. What an action is describing a user is describing an event, and reducer is describing what an action's impact on what action has what impact has that action on the state. Hey, I'm going to, well, update the state, or um, log out, or in Redux Toolkit, actions and reducers are grouped together in slice. For example, a shopping cart slice will combine both the reducer branch that changes the state and the actions. Each slice has its own exclusive actions. As a result, action has become glorified state setters rather than being broad description of the event. This probably doesn't sound like a big deal, and it is impossible for me to explain if you haven't worked in large classically structured Redux apps, but honestly, it's totally at odds with how I think should be used. I do not understand why the Redux team has made this change. As I mentioned, the number one complaint about Redux is too much boilerplate. By consolidating actions and Reducer, it means the developer doesn't have to hop between the actions file and the Reducer file, and then spend less time writing code. But here's a question: is this boilerplate really that bad? I mean, it must be if it is the first complaint, right? But think about if Redux was offering a ton of value. If it was an indispensable part of your stack, would you really mind spending a few seconds now and then creating explicit actions? When I worked at Khan Academy, we used Redux, and honestly, I didn't add much value for us. We didn't have a ton of global client-side states, and so it is so it kind did feel like we were spending too much time on Redux boilerplate relatively to how much value we were getting from it. When I work on an app with a lot of client side state, however, the boilerplate is absolutely trivial compared to the amount of benefit I get from Redux. It is not even close, but a big part of why Redux is helpful is a crystal clear event log. By squashing actions and reducers together, we send away one of the most useful part of Redux. And so I continue to use classic Redux here, but it's scribing here. And bonus input cheat sheet. There is a lot of different forms controls of the web, and it can be hard to remember exactly which property each one of them. I suggest in bookmark this lesson. Text input. For control text input, we bind the React state value attribute, and we can set initial value for uncontrolled text input with default values. And here's some gotchas. And the text input variants, where it say, hey, this is the things as it is. The text input variants, for example, in password, radio button and checkboxes, text area. Here's the value and on change. But again, it create now that and some gotchas here. Radio buttons. Iterative control example. So map each one of them, wrap them into an option, okay? And here's the input radio that is going to map this and say, hey, is this option is the same as the language? We define this as a state. All right. Okay. Cool. And it's render that again. So when it click here, it's rendering that element again, and so on and so forth. So if we inspect a little bit the code here, like this. So if we inspect the code, as you can see here, it has now all of these elements here that are rendering. All right. So when you click, on one of them, oh, look at this, it doesn't even show this. Oh, there you got it, it's here. Strong selected language. It's now Arabic. It's now this. But look at this. React, what it does is to update exactly the in a surgical precision, the attributes or these difference here. But for all of those elements here. And then apply that necessary change to that, and even here as well. And the check boxes, the default check. Multiple check boxes. So you define this as an object. You define here as a multiple objects here. And when that change, you want to now recreate this new object with that particular option name and the value as it is. And the similar for the select. Exactly, the value must match the selected value. And especially specialty inputs like this. Gotcha, range input and string. But all of this is just to describe is this. And now understand not only this particular tricks, but be able to describe this as it is, man. But being able to describe it as it is, man. And why we're looking at the complex states. And it's all about understanding now JavaScript. And it's all now understanding is JavaScript. And then now a project here, a war game. Well, that'll be all for this video. Take care. Bye bye.